All right, the first thing we're going to do is restrict this domain so that we can find an inverse. And what's going to help me here is I'm going to draw it out. So if I was to draw out this, or even put it in my calculator, I'm going to get something that looks like this. So there's an absolute value. Well, that's not one-to-one, because if I draw a horizontal line, it's going to hit twice. So what I need to do is I need to restrict it right here, and I need to know the value is going in this direction. So my domain in this case is going to be x is greater than or equal to -2. And my range is going to be y is greater than or equal to 0. So if I, again, go back and look at this and draw a table of values, x, y, my x values can be -2, -1, 0, 1, and if I fill in the corresponding y's by plugging it into the equation, I get 0, 1, 2, and 3. And I could plot those points and they would line up. So now, when I find the inverse, all I'm doing is I'm switching these two numbers. So my inverse, so let's call that f of -1 of x. If I was going to make a table of values, I'm going to have 0, -2, 1, -1, 2, 0, 3, 1. So 0, -2, 1, -1, 2, 0. And you can see right here, I'm just creating a line. All right. So now we're going to look and focus on the inverse. Right now, this is y equals, and I'm going to throw a little shift in there. All I want is the positive values. I don't want the negatives because I don't want the left side of the graph. So I'm looking at y equals x plus 2. To find the inverse, I'm going to switch my x and my y and solve for y. So I'll subtract 2 to the other side, so I have x minus 2 equals y. Therefore, my inverse is f of -1 of x equals x minus 2. The last thing here is we need our domain and range, so we're focusing on the red graph right here. Well, my x values for my domain are greater than or equal to 0. And my range values, well, the bottom of this graph is at -2, so it's greater than or equal to -2. I hope you see the connection here, and notice that the range here became the domain here, and the domain became the range with the numbers, because the inverse is when you switch your x and your y values. Looking at the second problem, we're going to kind of start the same way. If I was to graph this, it would look something like this. At 5, I would have a downwards parabola, but I only care about this side of the parabola. So my domain in this case is going to be from x is greater than or equal to 0, and my range is y is greater than or equal to 5, because that's the highest part of the graph. All right, if I was to make a table of values, I would go 0, 1, 2, and so on. If I plugged in a 0 here, I would get a 5. If I plugged in a 1, I would get -2 plus 5, which is 3. And then I would get -3 here. So we're going to find the inverse. And the inverse is going to switch these two pieces. So my inverse in this case is going to be 5, 0, 3, 1, -3, 2. So 5, 0, 3, 1, -3, 2. So it's going to look something like that. All right, so let's go ahead and find the inverse. So I'm going to start with my equation right here. And I'm going to switch my x and my y. Then I'll start solving. I'll move the 5 over, so I will subtract that. And I'll divide everything by a -2. So I can write it a few different ways, but let's just go ahead and leave it y squared equals x minus 5 divided by negative 2. Probably a better way to write that would be to change the signs of everything. And then the last step is to take the square root of both sides. But because our domain, we want our positive values, then we're going to have y equals, and we'll change that y right now to f of negative x. It's going to equal the square root of negative x plus 5 over 2. So my domain and range, I'm just going to focus from here, or the graph here. My range and my domain. So my domain is going to be x is greater than or equal to 5. And my range is going to be y is greater than or equal to 0.